Hello everyone. This is the video presentation for our IA2 of secure coding. This report is made by Aaryan Golatkar, Darshan Gupta and Sai Jadhav. So let's start. Talking about the summary of the report. This report highlights the processes of creating a vulnerable dummy website in PHP designed specifically for security testing and learning purposes. This website contains four well-known vulnerabilities commonly found in web applications, which are SQL injection, cross-site scripting, local file inclusion, and file upload vulnerability. These vulnerabilities are deliberately introduced to simulate real-world security issues that can be exploited by malicious attackers. Each vulnerability is thoroughly documented with detailed descriptions, vulnerable code snippets, exploitation methods, and recommended patches to secure the website. The purpose of this project is to understand the nature of these vulnerabilities, how they can be exploited, and most importantly, how to mitigate them to ensure secure coding practices. So for this, our chosen programming language is PHP. PHP is a widely used open source server-side scripting language, especially suited for web development. It is embedded into HTML and provides the backend logic for many websites and applications. PHP was chosen for this project due to its extensive use in web applications and its reputation for security vulnerabilities if implemented incorrectly. The four identified vulnerabilities, SQL injection, cross-site scripting, local file inclusion, and file upload vulnerability, are all common issues in PHP-based applications when security best practices are ignored. So now Aryan will continue with the demonstration of these vulnerabilities. He'll explain about the vulnerabilities, their vulnerable endpoints, and the exact fixation for these vulnerabilities. Thank you.
Hi everyone, my name is Aryan and I'll be demonstrating all the vulnerabilities in this report. So the first one is SQL injection. Here an attacker injects malicious SQL query so that it potentially executes in the backend, thereby retrieving unauthorized access data to the passwords or the usernames. So let's begin. I will show you the vulnerable code here. So this is the vulnerable SQL query. Here, as you can see, there is no sanitization involved. So what I'll do is, you can see this is the username and this is the password. So I have to enter something in this username which will bypass this entire query, and for that I'll simply enter admin 1 equals 1. Admin is a default username that is present in almost all the databases. The OR is a conditional statement. 1 equals 1 is always true, and the hash signifies a comment, so the rest of the query does not get executed. So I'll enter anything here, and we have successfully bypassed the login page, and this is how we can gain access using SQL injection. So the fix for that is available in the code right below. First of all, let me just comment this out. Now let me uncomment this, and as you can see, the security that I'm placing here is called placeholder. So if you see this question mark here, this is the parameterized query. So in the next line, as you can see, this takes the username as a string instead of an SQL query, thereby it does not execute that code. So now also I have done the password verification at a later stage. This will further enhance the security. So let's do this again. I'll log out and I'll try that payload once again. Let's see if it works or not. As you can see, please enter a valid username or password. So this is the message that we get, and this is how we can prevent an SQL injection. So this was the first vulnerability. Let's move on to the second one, which is cross-site scripting. So this is present in the manage user.php. Here, if you'll see, this is the fixed code, but let's comment this out. I would want to go to the vulnerable code first. Yeah, so this is the vulnerable code. It takes the username and password without any checks or imbalances. So let's try this first. This is the endpoint which is vulnerable. I'll go to the add user section and let's enter a basic payload like script alert 1 script. Now since there is no input validation, JavaScript code will get executed. I'll hit on submit, and as you can see, we've got the alert 1 right here. And on top of that, this is a stored XSS. So whenever someone visits this page, let me just reload it. The code automatically gets executed. So it is a very high vulnerability in the bug bounty programs. So how do you fix this? What I'll do is, let's uncomment this and uncomment the fix code. So here I have used a function called HTML special charge, which automatically escapes the script tags, the code sections for the username and the password both. So this is the function format in which you have to put the HTML special charge function. And now I will just delete this, add a user. Let's type in that again. And as you can see, no code has been executed. Let me just refresh it again. As you can see, no code has been executed. This is because I have escaped all the special characters. And this is the power of the HTML special charge. This will help us secure our website against cross-site scripting. So this was the second vulnerability. The third one is local file inclusion. So local file inclusion is a vulnerability where an attacker can read the local files present in a system in an unauthorized way. So for that, let's go to the code. This is the vulnerable code section. Here it is taking a parameter, a get parameter from the page, and it includes that file to the website. So the vulnerability here is there is no checks being performed. Like we can put whatever file we want and include that. So that's what I'm gonna do. This is the page URL, and I'll just type in page, and we can name in any file. So for example, I have taken this host file location, which contains the mapping of domain names to IP addresses. So I'll just hit enter. I'll just see the source code, and as you can see here, we can simply read the host file. All the information here is available, and you can read any other file you want if you have the permissions for it. So this was for local file inclusion. Now to prevent that, let me just comment this vulnerable code and uncomment the fixed code. So here the simple check is that we only allow some pages to be read, like the dashboard page, the users page, or the contacts page. If these pages are in the array, we'll append that to a .php so that only PHP files are being run. Else it will just include the header.php. So let me reload this. If we reload this, we won't see anything because I've fixed the code. But for another time, I'll just show you. Let's include dashboard.php. Now this would give me the dashboard.php, and it won't give me any other files. Like just enter dashboard. So yeah, this was the fix for local file inclusion. Let's move on to the last part, which is file upload vulnerabilities. So file upload vulnerabilities occur when we can, as an attacker, upload any file to the system, like a malicious PHP script, and it is not being verified or checked. So let's do that. I'll go to the upload.php section. It is actually present here in the code website, the upload file. So as you can see, I can upload any kind of file I want. But first, let me just uncomment the vulnerable code to show you what the vulnerability actually is. I'll comment the fixed code, and here you can see this is taking a post request to the upload variable, and then the file is being stored in the uploads directory. And here I've just included HTML special chars so that no XSS is being executed. So yeah, I'll just upload a PHP shell which is present. Okay, I need to make a PHP shell, so I'll make that right here. I'll name the file shell.php, and let's PHP web shell. Easy, simple PHP web shell. I will just copy this and paste it here. So this is the shell.php that I've created. Save this and let's upload that file. This is the file shell.php. Upload it, and the file has been uploaded without any restrictions. There is no like security checks in place. So if you see in the code, this has been uploaded in the upload/ directory. Let's go to that directory and check. Okay, so it is /expense/uploads. So I've already uploaded some basic files, no need to worry about that. Let's move to shell.php, and if I'm able to execute anything, as you can see, I'm successfully able to execute the code. So this is the file upload vulnerability. To fix this code, let me first just comment this, uncomment the fixed code. So there are a number of checks being placed in the fixed code. First of all is to ensure that the directory is not within the public web root. The second is I've kept a limit for the file size, so no more than 2 MB file sizes are allowed. Then the most important, I've kept some allowed file types like JPG, JPEG, PNG, GIF and PDF. Only these 5 file types are allowed. Rest all of them will be blacklisted. And for other safety purposes, I've generated a safe random file name to prevent any brute forcing from happen. And this is the check that will be performed to allow that only these 5 file types are allowed. Another check for the file size, and a third check to check if that the file is actually an image or not. So this is done by using magic bytes. If you know, magic bytes are these headers that indicate what type of file is it. Is it a JPG file or PNG file or any other file? And lastly, we move the upload file to the safe upload directory. So now I'll again try to upload the shell.php. Let me just refresh this. Now I'll upload the shell.php again. Click on upload file. And as you can see, this has not uploaded this time. The error, which was this one, only JPEG files, PNG, GIF or PDF files are allowed. This has popped up, and this is how we can prevent a file upload vulnerability. So these were all the vulnerabilities and the demonstration, and also the code fixes. All of this has been provided in the GitHub link. You can check it out for yourself, and thank you.